In this video we are going to see the most important NDT interview questions and answers of magnetic particle testing. Questions 1. What is meant by magnetic particle test? Magnetic particle testing is a non-destructive process used to detect surface and subsurface discontinuities in ferromagnetic materials like nickel, cobalt, iron and their alloys. Questions 2. Explain the steps in magnetic particle testing. Preclean the specimen. Induce a magnetic field in the specimen. Apply magnetic particles to the specimen's surface. View the surface, looking for particle groupings that are caused by defects. Demagnetize and clean the specimen. Questions 3. What is dry magnetic particle inspection? In this magnetic particle testing technique, dry particles are dusted onto the surface of the test object as the item is magnetized. Dry particle inspection is well suited for the inspections conducted on rough surfaces. Dry particle inspection is also used to detect shallow subsurface cracks. Questions 4. What is the maximum depth that magnetic particles can detect a discontinuity? 1/4 inch, approximately 6 to 7 millimeters. Questions 5. What is the principle of MPT? Principle of MPT is as follows. When the workpiece to be inspected is magnetized, magnetic flux is induced. If there is a flaw on the surface, magnetic flux leaks into the air at the position of the flaw. Then magnetic particles, wet or dry, are applied to the surface. Principle: magnetic flux leakage. Questions 6. Can you do MPI on stainless steel? Stainless steel is simply not magnetic enough. Stainless steel can't be inspected by magnetic particle testing as we aren't able to induce a magnetic field on the stainless steel. Due to this, the material remains non-magnetic. But only austenitic stainless steels that are not capable of magnetization, ferritic stainless steels, are actually magnetic. Questions 7. What is the lifting power of yoke during calibration? The magnetizing power of yokes shall be verified prior to use each day the yoke is used. Alternating current electromagnetic yoke shall have a lifting power of at least 10 pounds, 4.5 kilograms, at the maximum pole spacing, with contact similar to what will be used during the examination. Direct current or permanent magnetic yoke shall have a lifting power of at least 40 pounds, 18 kilograms, at the maximum pole spacing. Questions 8. What is minimum and maximum prod spacing during prod MPT? Maximum prod spacing shall be 8 in. 200 mm. Prod spacings of less than 3 in. 75 mm are usually not practical due to banding of the particles around the prods. Questions 9. How much particle settling volume is required during wet MPT? For fluorescent particles the required settling volume is from 0.1 ml to 0.4 ml in a 100 ml bath sample. For non-fluorescent particles, the value is 1.2 ml to 2.4 ml. Questions 10. What is the code and acceptance criteria for magnetic particle inspection? MPT shall be done as per ASME boiler and pressure vessel code, section. Section B, Article 7. Acceptance shall be in accordance with ASME boiler and pressure vessel code, Section 8, Division 1, Appendix 8, video in the channel playlist. Questions 11. What is the use of pi gauge in magnetic particle testing? The pi gauge is a tool for quickly verifying the direction of magnetic flux on a surface. It is made from 8 ferrous segments, brazed into a single piece, providing a star pattern of non-ferrous discontinuities. Questions 12. How much light intensity is required for MPT? The minimum light intensity shall be 100 Fc 1076X for visible color contrast particles. For fluorescent particles, UV lights shall achieve a minimum of 1000 microwatt per square centimeter on the surface of the part being examined throughout the examination. It shall be performed in a darkened area with a maximum ambient white light level of 2 Fc 21.5 lux. Questions 13. What is demagnetization? How to do it? The removal of residual magnetism by simultaneously or alternately reducing the strength and reversing the direction of a magnetic field. Generally, two methods are used for demagnetization. I. The part is placed in the field of an AC coil and withdrawn slowly to about 1.2 to 2 meters away. Small parts should be kept close to the ID of the coil. Each part is subjected to a reversing, diminishing DC or HVAC current.